Thank you, Ken. So for the next hour until the break, we're going to do our first panel. Okay, and this first panel is going to be on scientific research. After the break, that'll be followed by science delivery. Then we'll see some examples of science and practice in action. And then at the end of the day, we'll have some interactive exercise. Okay? So to set the stage, we're going to do the following. We're going to have 4 speakers come up and give a presentation on their research.
Although trained.
Excuse me.
Although I'm trained as a scientist, I am.
So I'm a scientist, by the way. So that's why we need an extension person, actually.
Sometimes people.
So we're going to have 4 speakers. They're all known here in California, but also nationally and internationally. Okay, and we'll be talking about scientific research and the rigor of research. What's rigor? And if you notice in this question we asked, you see science, you see research, but you also see urban forestry. So yes, trees will be a common theme, but you'll also hear about artificial intelligence. We'll talk a little bit about urban ecology. We'll talk a little bit about urban soils, participatory science, and we'll talk about tree monitoring. So we have these 4 speakers, all right? We're gonna have each one come up, give a quick presentation on their research and give their take on this question of what is rigorous research. And at the end, we'll ask them to come up here to the front and then we'll have a discussion, okay? So our first speaker, Profe, is Darrel Jenerette. And keep in mind that QR code also has everybody's bio. So rather than giving these long introductions, you can read up on their research, where they're from, what they do. Okay?
And just a note for our speakers, we are filming, so if you could actually stay near the podium, you won't just be a voice on the video. And we have a timekeeper right there, Mariana, so we're keeping you honest here.
It's on. Okay? Yes. Timekeeper will be there. 3 minutes already?
Great, thank you for the opportunity to speak here. I really appreciate this. It's an honor to be able to kick off this workshop, this symposium, and I'm really thrilled to have a whole bunch of practitioners in the room, which is a group of people that I really need to communicate and connect with more. So this is a really exciting event for me. I want to just lead off about talking about rigorous science and urban ecology.
I'm so sorry. Can everyone hear Dr. Jenerette?
Louder?
Maybe the handheld mic seems to be a better option. Thank you, Darrel.
So I took the prompt of what Francisco had gave to us, like what is rigorous science, and I tried to put it into a little bit, nuance it into what's useful science for us in particular. And this idea of convergence is one that has really gotten popular in the literature, and there's a lot of interest in this convergent science, which is this interaction between problem solving and rigorous science. So the problem solving side, issue motivated, place-based research, co-production of knowledge, so working together with people who are going to actually use the results, and the results inform action. I think this is in contrast to rigorous science, or in partnership with rigorous science, where instead of being issue motivated, it's question motivated. You want to learn something. The research is validated. The research is data informed. It's transparent, replicable. There are appropriate conclusions based from the results. And the results inform models. The results inform how we think about the world, not necessarily informing action. And this convergence in between here is really, I think, an exciting space for thinking about how we can use rigorous research in making urban forests, urban communities, Los Angeles, a better place to live. When I think about urban forests, one overarching framing that I've gotten for this is the novel ecosystem concept, where these are ecosystems that have no natural analog. The environments are novel. There's no environment like an urban environment for any of these forests The species communities are novel. These species have no evolutionary interaction between each other. The species come from all over the world, especially in Los Angeles. And then the traits are actually novel as well too. If you look at how the plants are functioning, they function distinctly different from what they would do in their native environment. So this novel ecosystem component works out really well. And I think about this in the context of like environment, species, traits, also the interaction with individuals, private government interactions. And I like this picture here, just like this is plant dispersal happening, which is a kind of a novel process in a forest, in a traditional forest. So the just new processes happening. I need to think about that when we think about urban forestry. And here's just examples of different types of forests that we have. They're all impacted by urbanization in Los Angeles, exactly. So what I want to do here is now go through like 3 examples of rigorous science that I think is not being conducted, and then 3 examples of rigorous science that are being conducted. So one thing that's not being rigorous is that urban forests reduce atmospheric CO2 concentrations. I think that is like gotten into our psyche so much that urban forests can be a mechanism to reduce CO2 concentrations. And the problem with this research is that most of the models that are doing this are not validated. We did a synthesis of 128 reported rates of urban forest CO2 sequestration. Only 3 measured pre and before, had 2 measurements to actually look at the amount of CO2 that was being sequestered. One of those showed a loss of CO2 in the forest, and that was due to mortality of the trees that was actually happening. So this CO2 sequestration is not really supported by strong science in the sense that it's not validated in particular, and the models are not well apportioned. We can see this for globally, and we also calculate this out, even if you assume what the numbers are suggesting, if you multiply out the rates of CO2 sequestration times the area of urban land on the globe, what this comes out to is 0.09 petagrams of carbon, which is less than 1% of 2023 emissions. So all of this effort to put in carbon through nature-based solutions in cities is less than 1% of emissions. So I think of this effort to use trees to sequester carbon is more an effort to avoid emissions reductions. There's a whole bunch of other factors that are not included in this, mortality, life cycle contribution. So I think that this is an area that research has not been effectively supporting actions on the ground. And I know that a lot of funding agencies depend on this CO2 sequestration. The second one I think about, not supported by rigorous research, is urban forests always improve air quality. Okay, air quality is it's not one thing. Like CO2 is one chemical. Air quality is almost an infinite number of chemicals with complex reactions happening between trees, in the atmosphere, and with the soils as well. So it's not just one thing. So I think that needs to get out there. And I think another part of why we end up thinking that air quality is improved so much by trees, if we look at the deposition onto leaves, certainly materials deposit onto leaves. If you pick up a leaf that's been sitting out over summer, it's pretty nasty. It's covered with particulate matter for sure. And but what does that mean in terms of actually reducing air quality? We can think of this, the example that I have heard and really speaks to me. If you look at a stream, the pebbles in the stream, they certainly get wet. They're not contributing to the amount of water in the stream itself, and that's the kind of air quality issue here. 2 major examples in how urban forests might not be improving air quality. 1, trees emit VOCs. So they're contributing to ozone formation directly, and then the VOCs themselves can be a reduction of air quality. Another one is this canopy effect often gets just completely ignored. And here's like a nice picture that I found exemplifying this. So if you're walking down this sidewalk here, the cars are moving through, this canopy effect is going to actually be exposing you to a lot more of this car pollutants right where you're walking. So this canopy effects are ignored, especially when you think about this deposition one. So this is, the rigorous science here is still happening. It's really complex science because you have processes happening at multiple scales and you have an infinite number of chemicals that you're trying to look at. So this is rigorous science on the pathway, but just saying that urban forests reduce air quality is not itself supported by rigorous science yet. The third one Native trees are best. This is not supported by rigorous science at all, in part because this is a value question. We have two questions within this. What is native? Are we talking about within California? Are we talking about within Southern California? Are we talking about like 50 yards away from here? Historically, most of Los Angeles would not be forested at all. There would not be native trees in much of this area. And then we think about like what is best. Like that is absolutely a value question. How you want to interact between the costs, the benefits, and your ethical concerns. I think that cost-benefit ratio is one way of thinking about it, but certainly there is an ethical component to thinking about using native trees and supporting biodiversity here. And I like this picture that was out just last year in the LA Times. This is jacaranda. Not everyone likes it. I love it. I think it's a beautiful tree. And this is the distribution of jacaranda throughout. So this non-native, this tropical tree is certainly a big part of our forest here in Los Angeles, and a lot of people like it, and for some people it could be the best. It's hard to say what is the best though. Okay, so that's three things that are not supported by rigorous science. I'll give you three things that are supported by rigorous science, and these probably won't be nearly as controversial. One, urban trees interact with a whole bunch of species. I think that is known again and again, and I think this example by Eric Wood is certainly a great one, where he's looking at the density of trees in the neighborhood and increasing with the migratory bird density, so you have more trees, you have more migratory birds in the neighborhood. On the other side of it, the polyphagus shot-hole borer is certainly a species of concern that is interacting with the urban forest a whole lot. And there's a lot of science that is achieving understanding how trees in the urban forest are interacting with other species. Urban trees reduce heat risks. It definitely cools off the environment. There's been shown in many studies have shown this for over 20 years, that urban trees are reducing the heat risks here. And this is just some work that I've done where we were able to fly a high resolution thermal camera over Phoenix in this example here. And so we can actually see the temperature of individual households. We can see the difference between the front and the backyard, the roof of the house. You see this day and night, and you can see like the thermal environment of people. Then we were able to have this really exciting study. This was funded by the National Science Foundation. So we did this flying at the same time as we were conducting interviews within these neighborhoods and asking people about their heat-related health incidents here. And one of the key findings from this here is, depending on the mean neighborhood daytime surface temperature, it showed an increasing number of households reporting heat illness in Phoenix. And so this is getting to like almost 60% of the households in some neighborhoods are reporting heat illnesses. And that is quite a troubling number of people that are reporting this. So we can make a connection between heat, trees, and people's well-being and their health. And it's exciting to see this work. Definitely leads into a whole bunch of equity questions, and there's a whole bunch of exciting work that is how we can improve neighborhoods and improve equity through the application of trees. I guess the final one here is that vegetation improves well-being. And this is definitely not my work, but it's been really exciting here. What this work here is showing the relative risk of mental health, and this was in Denmark. As one example, this is the greenness decile, so in more green neighborhoods up here, the risk of mental health issues dramatically went down all over the country. We can see that this well-being is improved by having more trees in your neighborhood, getting more trees in your area, more greenness in your area. It's still challenging, but what is the mechanism here? That is not figured out well, but it certainly is shown again and again in many presentations that vegetation improves well-being. Okay, so looking forward, what I think, and concluding this up, knowing the benefits and the limitations is key for managing urban forests and reducing environmental risks. If we want to improve people's lives, we need to take advantage of trees wherever we can, and we don't need to think of trees as being a panacea for everything, because they certainly are not. No, there are challenges with using that, and some of the challenges, global climate change, air quality risks are really important, and we're incorrectly investing funds into how we're managing those challenges, then that is a wasted opportunity. Urban forests are novel ecosystems. Their non-urban analogs can certainly be incorrect. Convergence research provides a rigorous and problem-oriented path forward to understand and provide tools that are actually useful for practitioners on the ground. And certainly more research is needed. And one thing I can see and suggest, contact University of California A&R. Tell them that you need to have more urban forestry faculty. And they make the decisions on this for the extension. And they have a table over here, so you can tell them directly, but probably a note to someone would be good. The extension is such an important part of the University of California. I'm really excited to be a part of extension, to be able to have that continuum from like the more ivory tower research to like working with people who are engaged with decision making immediately, and having more urban forest oriented faculty would be phenomenal. So thank you.
Dr. Kirsten Schwarz from UCLA. Keep in mind, the QR code has all their bios and information.
All right, thank you very much. Can you hear me in the back?
Not so well.
Closer?
Yeah, there you go.
All right.
Better.
It's a little awkward with the handheld mic. I'm not used to it, but we'll make it work. Good morning, everyone. It's a pleasure to be here and have the opportunity to share a bit about my work. Really appreciate the organizers for putting this panel together, and all of you for taking time out of your busy days to participate today. So for this overview today, I wanted to kind of take a step back and share my perspective as an academic researcher as what I see this kind of shifting practice of doing science. And I thought that was an important conversation to have with this group. We have a shared goal, shared values around maintaining the urban forest. And I think a really powerful pathway towards realizing that goal is partnerships among practitioners and researchers and communities as well. So the prompt for this panel is, what is rigorous research? And so I wanted to acknowledge first that there's been times where the concept of rigor in research has really been used to limit who participates in the process of research. So there are many ways in which Western science has narrowly defined the process of science and who does it, right? So when we do searches for stock photos around research, we see images still like this, right, that are done in a very controlled setting, usually by men and always involving brightly colored liquids. Right? But our definitions, I think, are really changing, expanding to acknowledge that there are multiple ways to do science, and engaging impacted communities in the process of science is really an important part of building social ecological futures and resilience. So this is work not from LA, this is actually from Newport, Kentucky. Newport, Kentucky is a small river city, and like many river cities in that area, they struggle with combined sewer overflows. So the stormwater and the sewage is in a shared pipe. When they have really big storms, that pipe system becomes overwhelmed, and there is sewage that is discharged into the Ohio River, which is a drinking water source for the region. So when we first engaged with this community and asked about biggest environmental concerns, it was not surprising to hear water quality, right? We also heard access to green space. So using those community identified concerns, we developed a project called Strategic Depaving, in which we worked with impacted communities in the city of Newport to remove impervious cover and replace it with green infrastructure that was co-designed by the community. So the outcome of this project was green infrastructure, right? But it's the process that I think was really important. So the process of engaging communities in the scoping and the development and the implementation of this work, I think it's the process that really enabled Strategic Depaving 2.0. So this work is continuing now, driven by our community partners, working with the city, where they're continuing to remove impervious cover and replace it with urban tree canopy. And they just received $1 million in IRA funding to support that work. And I was reading this morning an additional $215,000 from the Forest Service to continue to increase urban tree canopy cover in the west side of Newport, Kentucky. So I wanted to also talk about what do I mean when I say engaged research? What is that? This is a definition from the National Science Foundation's Committee for Environmental Research and Education, and there's a few important points that I really wanted to pull out here. It's conducted via meaningful collaboration among scientists and non-scientists. It explicitly recognizes that science alone is not enough. It's not enough to ask the right questions. It's not enough to enable new discovery. And most importantly, it's not enough to then translate that new discovery into action. So within that report, they also reference this paper that pulls out some best practices or principles of community engaged work, and that is that it is context-based. It's situated in a particular context, place, or issue. It's goal-oriented, right? So there are clearly defined and shared goals across participants. It's pluralistic. There's multiple ways of knowing and doing the work, and it's interactive, right? It's an ongoing learning process. Frequent interactions are emphasized. So we were also tasked with giving examples from LA. So I wanted to share some of our work on the Healthy Soils for Healthy Communities. So this is a urban forestry symposium, not an urban tree symposium. So it does include trees and soil. The Healthy Soils for Healthy Communities initiative is a unique collaboration among local and regional nonprofit organizations, local and federal governments, community groups, university partners, to better understand urban soils in LA County. So our role in this work was to engage with communities and find out what do folks value and prioritize for research and action. We conducted a series of 7 virtual focus groups, engaged with 41 individuals. We talked to folks that garden and grow food, folks that are involved in policy and practice around urban soil, and community, nonprofit, and coalition groups that might not be focused on urban soil, but their work is closely aligned with urban soils. And they had different things to share, right? There were concerns around contamination, there were concerns around funding, there were concerns around communication, land access, tenure. But there was also some commonalities, right? And these are the threads, kind of the shared concerns across all of those different user groups, right? So there's a need for accessible and transparent soil data and testing. There's a need for effective community engagement and streamlined communication that really centers underserved communities and the work that they're already doing, and building alliances among community policy, businesses, and science professionals. So this was really a first step for us in co-developing a community-engaged research and action agenda. And we're continuing that work. We have some recent internal funding from the UCLA Center for Community Engagement, their social impact collaboratives. And this is really focused on strengthening and expanding urban soil networks across LA. So unique about this funding is that it's really focused on relationship building and expanding networks on a certain topic. So we have a few organizing partners within this work, including Tree People, Physicians for Social Responsibility, Communities for a Better Environment, and Watts Labor Community Action Committee. So I wanted to share this new work for 3 reasons. 1, if you're doing urban soil work in the LA region, we would love to work with you. 2, I think there's a great need for this kind of funding. This kind of funding I think is unusual, funding that is specifically dedicated towards building relationships and trust among different user groups. I'm really excited that UCLA is offering this kind of funding, and I hope that we see more of it coming out. And 3, I wanted to emphasize that the process of doing this work looks a little bit different. So we've had our first meeting with our organizing partners, and the entire conversation was around expectation setting. What has your experience been engaging with university partners in the past? What's worked? What hasn't? What are your expectations for this group? So it's a really different conversation that we're able to have, again, because we have this dedicated funding that is focused on building that relationship, building that strong foundation to do the work. I had a few lessons that I wanted to share, things I've learned along the way that I think are echoed by others as well. One is that engagement at the beginning is always a good idea, right? Our default mode as researchers is usually to develop the questions in isolation and then go out to other folks. And that means that we're always working backwards, right? To convince folks these are the right questions instead of co-developing those questions from the beginning. So I want to emphasize the importance of engagement, but also the timing of that engagement and continued engagement throughout the process. Centering equity and focusing on the process. So in research, we also tend to be really focused on the product or the outcome, right? In this work, I think it's really important to instead focus on the process. How we get there is equally important. Who is involved, welcomed, invited along that process, again, from start to finish, keeps equity and better science, I think, at the heart of what we do. And I also wanted to emphasize the importance of listening. I had mentors in grad school tell me as a researcher there were 3 things that I needed to do to succeed as a researcher, and that was publish, publish, and publish. Yeah. Right? And so I think the parallel in doing this kind of work is to listen, to listen, to listen. Right? It's really important. I want to end with this framework that's been useful for our work. This is a framework that was published by Morrison in 2015, and this is called the Virtuous Cycle Framework. And what we see here is we have this kind of lightning bolt that represents an intervention. It's grounded in a specific place, right? So you have that intervention that's happening in a specific place. It has direct benefits to nature, so that's that kind of arrow going back up to the trees. And when those environmental benefits are realized by people, this framework argues that there's this positive kind of reinforcing loop that happens, right? Through action and through support of people that are realizing that environmental benefit, it is maintained. So we've kind of built onto this framework to suggest that if that intervention isn't engaging with communities in which that intervention is embedded, you can imagine that lightning bolt is a urban forestry intervention. If it's not supported and the folks that are influenced by this intervention aren't engaged, that's a way that kind of positive reinforcing loop can really weaken or even disappear. Right? And in contrast, hopefully I've conveyed the idea that engaging communities that are embedded in that specific place, in that intervention, is a way that we can kind of strengthen and maintain that positive feedback loop, ensuring those environmental outcomes, and hopefully more resilient social ecological futures. Thank you so much for your time.
Give it our next speaker, Ossola, University of California, Davis.
Okay, thank you. Thank you, Francisco. Thank you for having me today. So today I'm coming from the land of the Patwin people. So I'm actually an outsider here, coming from California, despite being Italian. And I spent 10 years of my life in Australia. I did my PhD in Melbourne. And today I'm going to talk about a couple of things I did in Australia, simply because Australia, it's kind of 10 to 20 years ahead compared to you guys in climate change impacts. Unfortunately, it's hot. Louder! Louder. Australia is hot. It's hot, very hot and dry. So unfortunately, we are ahead in terms of these impacts. So I spent quite a bit of time lately co-producing science with our own stakeholders. So I'm going to show you a bunch of things, how we do science together, right? Not to write a mural on, downtown LA, since you have so many anyway, but just trying to see how we can translate some of the learnings into a different type of environment like yours. Any of you had an issue like this, a pipe full of tree roots? Wow. Hands up? Yeah, not many. I actually had my own duplex in Davis. This is actually from California, right? In Australia, Sydney Water, which is our water utility, spends about $20 million a year to service this type of problems, right? Only on public pipes. It's a huge amount of money, right, that we are literally flushing down the drain. So in this case, we convinced Sydney Water to reinvest $1 million out of this 20 to try to do research and try to fix this problem for river, right? So I need to acknowledge a lot of different people here. And we try to use an approach that is kind of novel, using big data and AI to model, first of all, which tree species are most potentially related to occlusions of pipes, and also using genomics to try to validate what AI does and predicts. So we had a lot of data. This is just an example. If you live downtown, Sydney is here, and then in the west, Penrith is like sort of Riverside, hot and dry, right? It's about 45 miles long, this gradient. Downtown is here. You can see that in some areas you have a high tree species richness where you have up to 35 species per square kilometer. So it's a huge diversity of species, right? Overall in Sydney we have 651 tree species planted just on streets, much more diverse than here. And by the way, Darrel, we have jacarandas as well, so plenty of them. So we try to figure out how we can use environmental data, tree inventory data, the occlusion data. You can see a screenshot of all the different pipe occlusions across the town. And we threw all the data to an AI model. So we created this data cleaning pipeline. We did a bunch of exploratory analysis to try to understand what's going on. I can tell you that during drought periods, the frequency of occlusions are spiking up because the trees are thirsty, right? So they try to find water where water is, and guess what? You have also a bunch of nutrients there. It's great. You have water, you have a lot of whooping, yummy things the trees can use. So we use actually a distributed random model forest using AI. We churn all these analyses, and guess what? We found that, unexpectedly, the frequency, number of trees per unit of length of pipe is the most important variable explaining tree root, number of root occlusions overall in the landscape. You have more trees, you have more root occlusions. Yeah, my paper in Nature. No, not really. Ficus microcarp was actually the second most important variable, and I'll explain to you why they're there. But if you look at all these other variables, not related to trees. The most important variables are related to your pipes or the environment. So what Sydney Water didn't quite like is that actually their pipes, their leaky joints in the pipes are the problem, not the trees. First lesson, so don't put the trees in jail. This is AI generated, by the way. Don't put the trees in jail, right? They are not necessarily the culprit. But what we did was also to rank all the different species from AI. You can see all different species here, ranked by the AI model, but also based on the relative abundance in the landscape. You can see Ficus obliqua here is the 5th most probable tree around tree occlusions, but is really, really uncommon in the landscape, right? So it means that where Ficus obliqua is, there is a high probability that, hey, it's going to intrude the pipes, right? The other thing you can see here, jacaranda is here. Okay. You can see that the same color is also listing species of the same genus, same genera, right? So there are some genera that are more probable to intrude the pipes. So now I need to thank one of our postdocs here in Sydney. And she's essentially sampling all the roots with Sydney Water crews. Every time there is an occlusion, Jesse is going in the field, working with Sydney Water crews. We are taking a piece of root. We are sequencing for DNA markers. We have already a DNA library from the leaves of these particular trees, and now we are validating with genomics all this AI galore that we did. Hopefully, we're going to help, first of all the different councils in Sydney. There are 35 of them planting the right species in the future. and hopefully trying also to find a way to mitigate this issue because, as you can imagine, it's a complicated issue. This is actually a fig root intrusion in pipes in San Diego. You can see here that the fig just dislodged the pipe and hasta la vista, right? So it's very difficult to fix this. Why figs? Well, because in nature, they have this rooting behavior, very aggressive. How we can try to avoid or improve species selection working with growers to avoid this issue in the future, that's something that I'm going to leave it to. Second project, much more ambitious. It took 5 years of my life. We work with the entire horticultural industry in Australia. Every pot in Australia has a tax levy of $0.00 nothing dollar. But it means that we are selling trillions of plants and we have funds to do research on this, right? It's a small levy. We got 10 million here to model the entire horticultural flora for climate change resilience. So we're talking about 2,000, 3,000 plants. And we did a lot of engagement. I traveled Australia a lot, loved it. Tell us as scientists what's your problem. We are here to help you out. We need to know, as a practitioner, as someone in the landscape, what's your issue? How we can help you using science in a creative way to find solutions, to have a robust evidence base. In our case, if you Google which plant where, you put your zip code here, it only works for Australia. Okay? We are working on an American version of it. But automatically, we list you all the different species. I'm going to skip this one for time, but you can see here that 2000 is zip code in Sydney. Automatically, we are going to listing you all the different species that we deem climatically suitable for that area by 2030, down the road 2050 and 2070. In this case, we returned 615 tree species. Plant species are not only trees. And then, of course, you can select your trees based on different traits, different aesthetic traits, different ecological traits, and so on. All of this was born because some of our partners told us that they had an issue. In this case, they are growers. In the other case, was Sydney Water. Tell us, as scientists, what you need. We are all public servants of the state of California, my colleagues, or federal scientists. We are here to help, okay? Do you like the sequoias? Coast redwood? Yes? This is the global temperature niche of Sequoia sempervirens. Sacramento climate was here. Sacramento future climate is going to be here, right? Now, if you live in Davis like I do, coast redwoods are everywhere. They are planted everywhere. More tragically, they are still sold everywhere. So we are planting failure, right? How we can help growers and you, stakeholders, trying to create a framework where we are making better decisions, we are influencing policies with better decisions. This is my challenge. And hopefully my legacy of my career. Now, where you go in California to see the real coast redwoods? Any idea?
Northern coast?
North.
Right. No, you go to Costco again. Sorry. It's actually pretty cheap, $44.99 for a nice tree, right? This is actually Sacramento. Now, we can't afford to screw it up because it's costly. It's really costly. Now we have an unprecedented opportunity before us to make it right. I know it's ambitious, but we need all hands on deck. You, us, I'm pretty sure it's a very bright green future if we work together. And this is all the people I need to thank you because they supported me for the last million years. And I guess we can take questions after in the panel. And thank you for listening.
U.S. Forest Service.
Thank you, Francisco, and thank you to all the organizers of this event. Like the others on this first panel, I'm very excited to be here today. Some folks I know already, some folks I look forward to getting to know. So I'm going to be talking about urban tree monitoring research.
keep the mic close, please.
Very close?
Yes.
This is better?
Yes.
There you go. All right. I can also just shout like this. Okay. All right, this. All right, so I'm going to be talking about why is monitoring important. So we want to understand how all these urban forests and urban tree systems are changing over time. Some typical goals of monitoring efforts, whether those are done by researchers, practitioners, or through collaborations, are to evaluate planting program performance, to evaluate the factors associated with tree mortality or survival, growth and health, and also to engage local communities. And the kind of monitoring that I'm talking about here is field-based monitoring, tracking trees on the ground. So it was mentioned earlier that we have new resources for urban tree monitoring. So Natalie Van Dorn, who's in the room today, and I co-developed these guides alongside about 20 other co-authors, including quite a few people in practice. So we have a field guide that is protocols for how to collect certain variables in the field, and then a resource guide that is more about tips and tricks and strategies for how to run a project, how to come up with good questions, and how to manage your data and manage your crews. And we now have these translated into Spanish thanks to international programs of the Forest Service and colleagues in Puerto Rico, and we have YouTube training series. So some of you might be wondering, okay, that sounds kind of similar to inventory, so how is it different? So I want to walk you through how we think of this research-oriented monitoring guide as being different from a sort of traditional management-focused urban tree inventory, so like a street tree inventory that a city might conduct or contract out for. So the purpose of that typical management-oriented inventory is to manage tree crew workflows. Where do you need trees planted, pruned, removed, stump grinding, and so forth. That data might also be used to understand some kind of basic descriptive things like current species distribution, size class distribution with diameter of breast height, DBH. But this is pretty different from the new monitoring guidelines, where we're really focused on assessing change and getting accurate and consistency is key, data to report on how mortality and growth and health of trees and population size are changing. To do this, we need to track the fates of individual trees. So when it comes to measuring diameter of breast height in that kind of typical street tree inventory, it's usually done to nearest inch, and usually the exact height point on the trunk of where you're measuring is not noted. So in the United States, that typical default height point is 4.5 feet. However, you often have to deviate from that for one reason or another, where the tree is forking, some kind of funny thing going on with the bark. And so in research-oriented tree monitoring, we record to the nearest 10th inch or nearest millimeter, and we note the exact height point on the stem so that we can remeasure in the future and accurately report on the growth of the trunk. So moving down to the last row on this, talking about data structure. So your kind of typical, say, street tree inventory is a static snapshot done at one point in time. Some cities that are well-resourced might be able to systematically update, but more typically it's sort of ad hoc updated, depending on where work and projects are happening. With the research-oriented monitoring, we have a dynamic longitudinal database. Longitudinal meaning tracking the fates of individual trees so that we can summarize all that information across the whole system, but it's tied to individual tree fates. So I want to give some examples. This first one is from Northern California with the Sacramento Shade Tree program. So if Ann and Cindy are in the audience, they were at Sac Tree Foundation when I was doing this work in collaboration with the utility district up there, the Sacramento Tree Foundation. So these are trees given away to residential yards. Some of them actually never get planted, unfortunately. Some then die after planting. So this project where we developed the questions and the methods and even some of the statistical models in close consultation with the practitioners, we found in all the different fancy ways that we analyzed this data, I won't bore you with, we found that homeowner stability was the driving factor. So this project started at the height of the foreclosure crisis. Homes that were unstable, they had rentership, they had people moving, they had foreclosure. These were the homes that were housing trees that were more likely to die. So those homes had 9.3% annual mortality for trees compared to 5.2% for the trees that were not, or were in stable homes. So this is a survivorship curve, which is typically found in epidemiology research. So that's part of the rigorous research. But the other, again, core part was the input of the colleagues in practice who are helping me get access to this kind of parcel level homeownership data and helping guide the questions at every step of the way. So another example is street tree monitoring that was done in collaboration with a nonprofit back in Philly. And so that's where I moved from 2 years ago. Now I live in San Diego. Anyway, so this project came out of the height of the pandemic. We weren't sure if we could safely do field research, so we used Google Street View to track the fates of the trees planted through this program. And so we monitored almost 3,000 trees. Some amazing students stared at screens all day to do this with me. So we complemented that with some volunteer-based citizen science data that's collected through volunteers with a nonprofit. And we found that survival was worse for trees planted in the spring. So in that regional context, plantings happen in spring and fall. So spring plantings did quite a bit worse. Trees surrounded by high levels of impervious surface, and also trees in neighborhoods with high social vulnerability. So these findings are directly informing some changes that the program is thinking about, especially as they are ramping up the volume of trees that they're planting thanks to new federal funding. So another example of street tree monitoring comes from permanent plots that we established in both Philadelphia and New York City. So permanent plots is a kind of tradition of doing research in forest ecology and other areas of ecology where researchers and their crews were really deliberate about the exact geographic boundaries of what are they monitoring. It's often like a circular plot or sometimes a transect, different kind of options. In the context of street trees, we set up a half-mile transect of road, but that randomly turns corners. So that's that funny red squiggly line there. And then we were very deliberate about what is a street tree. We knocked out certain species in Jenerette that tend to be more shrubby. We were very careful to be in constant contact with our crews to say, that tree's out of our bounds, it's too close to the home. We were very careful about all of that. And this way we're able to talk about net changes, right? So if you have two different street tree inventories done by different crews that are interpreting what is a street tree in different ways, do you know if your number is increased or decreased? So we were very careful about all those steps. And now that we have a baseline from 2015, we remeasured in Philly in 2021, we hope to go back and then we can start looking at the impact of all these new trees going in the ground, again, through Inflation Reduction Act funding. So now as I close out, I want to mention a new project that we have about trees in schoolyards, which has been alluded to earlier. The purpose of this work is to characterize tree resources, doing inventories on elementary school campuses, focusing pending permission from school districts on Los Angeles, Oakland, and Sacramento City Unified. So we want to evaluate the climate vulnerability of the species mixes that are present. We want to use some sensors to evaluate microclimate benefits, and then we want to do some social science investigations to understand who's responsible for different parts of the tree life cycle and project life cycle, who initiates, who plants, who maintains. Also understanding the varied perspectives and complex interactions among these different stakeholders, and really balancing the benefits of trees versus the challenges of trees as they exist in these complex landscapes. And we have an amazing project team. Natalie Van Dorn and I are the co-leads from the Forest Service side. We have folks from state and private side of the Forest Service. We have CAL FIRE. We have several colleagues from the University of California, including Kirsten and Ale that you've already heard from. Green Scholars America, but then we also have the local practitioners, some of whom are in the audience. So if I've been chatting with you, if Natalie and I have pulled you into calls, it's because we really value and depend on your expertise. We're not going to be approaching this project the right way unless we learn from people who are in the trenches doing this work. And so to kind of reiterate some of what Kirsten was saying earlier, I firmly believe that co-produced science and science that's built through deep collaborations across the research practice divide, it creates better science. And I want to refer to the 3 R's. Reach. We get access to the right data. We interpret that data correctly through talking to our colleagues about what the data means, and then sharing results back. Rigor. We are asking the right questions and nuancing those questions based on what's actually happening on the ground with management. And also relevance. Sometimes if we PhD heads publish and it goes in a journal, it gets dusty, nobody looks at it. We need to work with folks at the local to regional level to make sure that it's getting back into the hands of folks who can best use it. And all of this is towards an ideal of the co-production of knowledge and the democratization of science. And with that, I will close out with some pictures of amazing people who've helped me with fieldwork over the years. And I think I turn it back over to Francisco now.
Okay?
So I think this question of what is good research, I just wanted to emphasize that I don't think there's just one model of good research. I think there's lots of different ways in which good research can happen. I think the good research that I'm most interested in doing is interdisciplinary, like really valuing the perspectives that different disciplines bring to the table. It's collaborative. and it's community engaged. That's the kind of good research that I'm interested in doing. I think the second part of the question, this kind of like balance of how much is enough research, is really interesting. We all want to make decisions that are informed, but I think researchers often frustrate by saying we don't know enough, we need more research, when action is what is really needed. So I think it really is a balance of trying to make informed decisions based on the information that we have, and not make the fact that we don't know everything really stall progress. Because researchers do have a reputation. I think we end every manuscript with like, more research is needed. Not to call Darrel out, but I think it was on his slide. And more research is always needed, but that doesn't mean that we can't move forward with action.
So echoing everything that Kirsten says, but adding on a few additional layers that's sort of what's expected of us. Good research for us to be evaluated. I mean, not speaking for everyone on this team exactly, but when Kirsten said publish, 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 that's a norm in our field, right? Publish or perish. But some other norms that are, I think, really important when we talk about good research or rigorous research is reproducibility and transparency. So often in the papers that we publish to advance in our careers, the methods sections are much longer than the results section, because we want to make sure that people know how we carried out that research. There'll even be in those methods section an allusion to some supplemental online material to learn more about the protocols and procedures. It's also increasingly expected of us when we publish that journals will require open data, and sometimes even open code for how you statistically analyze your data. And so that all creates that reproducibility that will enable, if a finding has been done in one place, one context, one program, for someone else to apply similar methods in another place to find out if the results or the magnitude of the impact or whatever it might be is similar in another place. Because some of the challenges that I think we've encountered in urban forestry is that some of the generalizations about whether it's certain benefits or certain relationships, they were done in one spot. So actually a lot of the work on building heat reduction was done in Sacramento and in other very hot parts of California. It'd be very difficult to apply that to the very cold areas of the upper Midwest, or to apply that to just other regions of the world. And so one of the other core things I want to point out about really carefully done research is acknowledging that we do always say we need more, but acknowledging the limitations. We found out this much, we still don't know this much. If some researcher on high ever says they figured it all out, I don't think they're that great of a researcher, because we always acknowledge the gaps in our understanding and in the extrapolation of a particular project.
Sure, I'll go next in line. What is good research, and this idea of more research is needed? I think that's a mindset of scientists, is that it's always opening new doors. Every single project that I complete is opening new doors and there's new things to explore. So that is a mindset that we get into. I think when is it enough research? That's a really important question, and I think there's a whole lot of issues that we know that we have enough research. We know, like, it's not perfect, it's fine, but we know what we need to do to actually make the world a little bit better place. And it's not always just the researchers who are falling back when we need more research. There's a lot of policy as well. We don't have enough science, so we're not going to make a decision that's going to be challenging. So I think that goes both ways onto where is that enough research identified, and I think it could slow down action. So again, to come back to this working together between people on the ground, definitely appreciate the suggestions to start at the beginning. Co-production is not a process at the end, it's a process at the beginning, and how do the questions actually get made. I'm working on a project right now that's trying to develop a tree planting tool to reduce heat and maximize water equity in the southwestern United States. And a big part of this whole project is how do we connect with people who are going to use this tool, not at the end when it's built, but like in the beginning. Like right now we are doing low fidelity prototype testing, where we have literally like really coarse pictures on paper that is meant to be low fidelity, so that the people we're interacting with do not feel like this is a finished project. It's very much a beginning, and we're trying to get our ideas to help the potential users on that. So I think that co-production is really important, and that probably is where we're going to need the most rigorous science. But I agree with what everyone said with what is good science already.
Yeah, just to maybe conclude, research questions. Everybody has questions, right? As scientists, we continuously asking stuff in our mind. They are not fixed. When we start a project, we have a general idea where we are going. We have our own initial research question, our own hypothesis. Guess what? Most of the time, I'm wrong, right? We are continuously carving, recrafting things and rethinking, taking step backs and trying things. It's like adaptive loop in our thinking. Like you as practitioner, most likely you don't have all the answers straight away. Right? So if we learn from each other how to merge these two different mindsets, that's really powerful because we can understand your needs and then we can reframe scientific questions onto our own canvas of ideas. It's challenging, yes, but it's doable. Hopefully all the different examples that we show you at the demonstration, that in different contexts, in different climates, in different social environments, we can do it. We can advance knowledge. Going back to research questions and how much research we need, I would argue that some of the questions that we addressed, we did it maybe at the beginning of urban forestry and urban ecology 20 years ago, but hey, we didn't know about climate change then. Well, we kind of knew, but conditions are changing. Our communities are changing. So sometimes it's actually good to repeat some questions that we had in the past because the underlying social, environmental, climatic conditions changed. And we don't know how urban systems are going to necessarily respond until we measure it. Measurement is everything. And finally, a last call. If you have data, we are begging for data. It might be gray literature data, maybe something that you measure, something that it's not science quality just yet, but sometimes having heads of how a system works from your perspective is actually helping us to make sure that we nail our assumptions and actually we infer the right thing without extrapolating crazy scientific ideas onto the wrong space.
About one follow-up there as well. I think one point on what is good science that you really, I think, alluded to strongly, which I feel is important. Good science is a whole bunch of failures and mistakes. I think one of my undergraduates I worked with, that person was just like shocked at how every single day something wrong happened, and it was just error after error. But we keep self-correcting, we keep learning from the mistakes, and then eventually the data and the results come together. So good science is certainly a process that is not just the end point of what we see.
We're going to do questions at the end. So one more question. Right? So you've talked about practitioners and collaborations. Can each of you give a quick example of a success story where you have worked with practitioners, or, since we're being transparent as we should be as scientists, where there's been barriers, limitations, maybe even failures with working with practitioners?
Well, I think I shared one of my success stories in the work in strategic depaving. That was, I think, a very successful collaboration with practitioners and also with community. So I'll share one of my failures. And that is a research project that I worked on as a postdoc. I was at UC Davis. We were really interested in getting some research up and running around soil quality and contamination and food production. And this, I think, is a classic story of academic researchers have a funding opportunity. They develop some research questions, and as part of their lab, they reach out to community groups to see if they'll write a letter of support for their grant application. And we did just that. We had some quick conversations with community organizations in the area. We found out about one that had a garden initiative, 350 garden initiative, and so we wrote this into our grant proposal that we were going to study these 350 gardens. We got lucky and we got funded, and we went back to that community organization and said, we have great news, we got funded, we're ready to do research on those 350 gardens. And they were like, we don't have 350 gardens. Like, that's the title of our initiative. It's like, it's aspirational. We have like 50 or 60 gardens. And so luckily that funding was really flexible, and we were able to direct some of that funding towards garden installation as part of the project. But I often share that story as just what happens when we don't really take the time to build the trust and relationship before we put in that grant application, right? We didn't have a shared understanding of their programming, of what the organization was all about before we proposed to work together. And I think that's a really critical part of doing this work, and it's one that we don't value enough, and it's one that we don't fund at all, usually. So we've after that happened, we've talked about this concept of soil money, the idea that we're all familiar with the concept of like seed funding to let's support a really cool research idea, but those seeds are a lot more successful if you have a soil system in place, right? If those relationships and trust are already in place. So we've made the argument that we really need soil money. We really need to be supporting the relationship building and the trust building that is so critical to making this work happen and be successful. So you don't have to have an awkward conversation about 350 gardens.
Do you have time for?
Yes,
Okay.
ideally a success story.
Okay, it will be a success story.
Good, excellent.
So with the Pennsylvania Horticultural Society, which is the program that runs this tree tenders group back in Philly, I was physically based in their office for years. The Philadelphia field station of my agency was based in their office. So we had these years of building up soil, I suppose, and trusting each other, such that when they said one day, you know, we're really struggling with why we don't have some of these tree tenders groups in North Philly. We have some initial ideas, but we'd really love to understand it. We're trying to improve the environmental justice of our programming and equity and going into neighborhoods that haven't historically participated as much. And, you know, we have some ideas. So I said, all right, we can do that. I know a new student at Temple's. This is Liz Reedman, who's now actually part of our school study here in California. And we studied barriers to participation. We ended up finding some things that reinforced lessons that some in practice already knew, but by doing it in this kind of formal, you know, rigorous capital S science way, we were able to, I think, shift around what the program was thinking. So to give some concrete examples, North Philly is a neighborhood that is mostly Black and brown residents. My parents actually grew up in neighborhoods adjacent to that, and later were social workers in those neighborhoods. When talking to community leaders in the neighborhood, some of them said, frankly, trees aren't the most important thing my community needs. Some said stories have circulated around the neighborhood of, you know, the city hasn't been investing in street tree care, and why would I plant a new one when they haven't even taken care of this other one that needs removal? And so a lot of what we heard was residents and community leaders' profound experiences with tree challenges, worries about future costs, lack of trust in the city, and also there was some positive stories around the potential for trees to kind of serve other needs. And when we brought this information back to the nonprofit, and we also designed it with them all along the way, it, I think, started shifting some of the ways in which they talked about trees. So for a long time, some of the staff would do, they called it like myth busting. Like, oh, you think trees cause this problem, you think trees damage pipes. Let me bust that myth. And it's that kind of a language, or that kind of a constant selling of trees are always good and hardly ever bad. It can feel just very disempowering and disingenuous to residents who've experienced those problems firsthand and had to often shell out lots of money. So I was really proud of that research. We then later got funding to expand it to some other communities in the city and the suburbs. But again, it took a lot of deep trust across lines for the nonprofit to enable this then grad student, now postdoc, to go and talk to people. Hey, why don't you like trees? They're like, what's going wrong here? Because we were all oriented together about problem solving.
Short one? Okay. Well, I think for, let's see, examples that are going to be successful. One, this is really challenging for academic researchers in particular, because our metrics of success by the university is focused on publications, at least at my department. And connecting with the community, connecting with practitioners is certainly appreciated. This event is really appreciated by my university that I'm participating in, but the hard work of actually meeting with groups like for weeks and weeks on end, that part is not appreciated by the university. So we're trying to work on to cultivate and make those changes within that. One success that I've had, I think, is about the same time that Kirsten was doing community garden soil contamination. We were also studying community gardens in Los Angeles and looking at the metal concentrations in here. And I think we were able to identify, like, there's a whole lot of metal contamination in some of these community gardens. And some of them are associated with characteristics that would make a lot of sense, like when they used old railroad track tire irons or the wood there. It's really contaminated wood, and that leaches out into the community garden soils. And we have a whole bunch of, there's other contaminants too, and it's really spotty. Like one place would be fine for lead. You go over 2 meters, and then it's like a really hot spot of lead, given the historical land use on the individual location. And so we were able to communicate that back to the community garden organizations, as well as to the individual members, and that was really exciting to get that back and forth with. It came back, it still is a trouble, because they would want to know, well, what do you think we should do? And I was like, well, I don't know what you should do. Like, how do I tell you? Like, I said, well, I can tell you what the metal contamination of the soil is, but like, that's one factor of how you're going to operate your community garden, and it didn't really lead to like a clear conclusion, like should you stop? I guess it was more like, well, you shouldn't have your kids be playing with the dust. Probably eating the vegetables are going to be pretty good, but I'm not a medical doctor, and I didn't want to even pretend to be one, and so it was hard, like how do I communicate these findings in a way that's useful for them in their decision making? I think that example still sticks with me as one. It was a success, we were able to get knowledge that they wanted, but we couldn't interpret it well for them, which is still something I think about.
Perfect discussion point for the science delivery.
Thanks.
So we're gonna make a little change here. We're gonna ask the audience to ask one question, all right? So there's 2 rules there. The third rule I'll ask is that it be about the panel discussion. If you have specific questions for the researchers, they'll be here during the break. You have their bio, you have their email, and this side of the room is being a little quiet. So first hand, why not? 3 rules.
I heard 2 things that are in conflict, and yet I agree with them. One was about the importance of soil building, love that concept, but you also said the pain of meeting groups for weeks and weeks on end. How do you shore up these 2 different things? Because it is the hard part, community building, and it's also the biggest time suck, but with the greatest rewards.
Yeah, that's a great question, and I'll just start out by saying I don't have the answer. But I do think it's something that we need to center and value. So at least from like the perspective of a university researcher, I'm really encouraged to see this new funding opportunity that comes out of UCLA from the Center of Community Engagement that's like, we want to give money for the relationship building part of this work. For me, that's really encouraging. I also feel like Darrel reflected on kind of our reward system within the university, and I feel like UCLA has made some really significant progress through that center in valuing the work that's being done by faculty. So that work is now valued as part of our promotion and tenure process. And that center continues to work across UCLA to see that community engaged work is also valued when different programs at UCLA are evaluated. So those things make me hopeful in terms of the university recognizing the value of doing that work. But in terms of like, I've wrestled with this in my career in communicating the work that I do, and sometimes, I mean, I'm sharing with my folks that are evaluating me just like lists and lists and lists of all the meetings that I'm going to, engaging with community, the labor that like maybe isn't recognized as part of that formal evaluation process, but just to have it recorded to say this is what it takes, you know, to build those relationships and trust. I guess one more thing is just, you know, partnering for again, from the perspective of a university researcher, partnering with organizations that already have that relationship and trust in the community is super valuable, right? So working with those folks that have already done that work, they have a long-standing reputation in the community is really an important partnership.
I'm happy to take other questions.
We'll stay with that question. That way we'll transition into our next.
No.
You know what?
I will just add that for the Forest Service side, that's what these urban field offices are supposed to be doing, is to helping to build those relationships so that when some funding comes along, it isn't, hi, you never heard from me before, let's do a thing. which happens a lot, and I've been guilty of that too, because sometimes that's the funding comes along in an area you don't know yet you were going to get that money. But in theory, these urban field stations, and all kudos to Francisco for working on this for the last several years, and Yassi in the back, building those connections throughout that city and county of LA, throughout the metro area, so that people are getting to know each other, so that questions and concerns are starting to be shared, and that the next steps can be taken as opportunities present themselves. When that work is completely missing, I've certainly actually seen on public health sector some really troubling cases of people who call themselves community engaged and they're not at all. Then it starts feeling like a kind of fake collaboration. But I think doing the groundwork without any end goal in mind of any one specific project, just meeting and getting to know each other and having each other's backs, it starts paying off dividends in the long run.
Darrel.
So I think maybe you hit it right on the head there, that twist between the hard part and the important part. And I think the funding mechanism is something that really needs to play in here as well too. We need to have long-term sustained funding that allows us to happen. It just can't be put on the backs of all of your work. You all have a lot of work that's already happening, I'm sure underfunded, as all of my work is underfunded as well too. And scraping by trying to make these connections. We really need some sort of sustained long-term funding. That's one of the things I like about the LA Urban Forestry Center, is that it is a house for that. So I guess that's what my plug would be. Funding is important.
All right, thank you. We've run out of time, but these folks will be here. So if you have specific questions about the research, want to continue the conversation, please feel free. We're going to be doing a breakdown.
We can take one more question.
Okay, one more question. Okay.
Yeah, this is regarding trees in California schoolyards. Great approach. Just wondering, are you all engaging division of state architects? Because I think all those school districts will benefit from more creative ideas and loosening of those strong regs that really take money from those programs. So just curious if there's any discussion on CAL FIRE's there, but that's something that tree people and others are working on as well, and we would appreciate any thoughts there.
The question was about the state architect. We have not talked to that office yet. We were very fortunate to talk to folks in the State Department of Education. CAL FIRE is one of our core partners. But yes, some students of Kirsten's right now are looking at the forces that created and reinforce extensive impervious surface in California schoolyards. Rather than focusing on the trees, focusing on the blacktop. So I cannot say for sure what the exact outcome will be of those conversations, but our hope is that by highlighting things that relate to school financing and rules and policies, we will be showing where some of the bottlenecks are that need to be modified.